Okay, section 2.1 to 2.5 review number 2. On this one, the goal is to find the limit of f of x as x approaches 0 from both sides for each of the following functions. So I will probably do all 3 of these because they each behave a little differently. If we look at all 3, we see that we have absolute values. Absolute values are piecewise functions in disguise. So if we want to do part A, my first job is to rewrite this function with its pieces. Remember that the pieces of an absolute value function are, we either leave the inside alone when the inside is positive, or we take the opposite of the inside when the inside is negative. So before we continue, let's look at when the inside would be positive and when the inside would be negative. No matter what x is, when you square it, it becomes positive. So 2 times that positive number is going to be positive the entire time. Sorry, that should be a less than. So that means we don't even get this branch because the inside of this absolute value is always positive. So we can rewrite that as a 2x squared over an x as long as x does not equal 0. Notice that x is not in the domain of the original function because we cannot divide by 0. Once we have this written, then we can simplify it and say that that's the same as 2x. Now notice we're interested in the limit of this function, which is equivalent to 2x as long as x does not equal 0. So I can rewrite this as the limit as x approaches 0 of 2x. Because 0 is not a problem for this, I can simply plug it in and get 0. So that's my answer. Now let's look at B. B, we have the limit, again, as x approaches 0 of the absolute value of 2x over x squared. In this case, when I create a piecewise function out of the absolute value of 2x over x squared, I will have one branch where the inside is left alone when the inside is positive. Oops. And I'll have the opposite of the inside when the inside is negative. If I continue on with this and simplify, I will get a 2 over x when x is positive, or a negative 2 over x when x is negative. So now that I have my pieces, I am ready to examine the two-sided limit. So we will approach that joint of 0 from the right side and from the left side. If I look at it from the right, that means I'm looking at numbers that are a little bit bigger than 0. So coming over here and looking at our branches, here are for x's that are bigger than 0. So I'm going to plug into the top branch. On the bottom one, when I'm approaching 0 from the left, I'm working with values of x that are smaller than 0. So that means the bottom branch will be appropriate. Now we're ready to compute the one-sided limits. If I plug 0 in and try direct substitution, I'm going to be dividing by 0, which is not allowed. The top number is not 0, so that means I have an asymptote. Because it is an asymptote, I'm really only concerned about the sign of the output. It'll either be positive infinity or it will be negative infinity. So if I plug a number a little bit bigger than 0 into the bottom, it will be a positive number and the top is positive. So the behavior of that curve will be heading up as we get closer and closer to the asymptote at 0. If I want to do this limit, I'm looking from the left side of 0. So that means little negative numbers that are close to 0. So the top will be negative, the bottom will be negative, and we will again end up at positive infinity. Because these two are the same, we can write that the overall limit as x approaches 0 of that absolute value of 2x over x squared is equal to infinity. The third and final problem, I'll write down here and then I'll scoot my camera up. We are approaching 0 again, and we still have an absolute value, so we need to break that absolute value up. So if we look at this, we again will have a piecewise function. We've got a 2x that can be written as the inside left alone, as long as the inside is positive, and the opposite of the inside, as long as the inside is negative. If I simplify that, I end up with a 2/3 when x is positive, and a negative 2/3 when x is negative. Now again, I'm interested in the two-sided limit. Because 0 is a joint on the piecewise function, I have to examine that joint from both sides. So I'm going to approach from the right, and I will approach from the left. When I'm coming from the right, I'm using numbers that are bigger than 0. So I locate the branch that has numbers bigger than 0. That's the 2/3. For this one, I'm approaching 0 from the left, so those are numbers smaller than 0. I look smaller than 0 in this branch, so I'm going to be using the branch negative 2/3. Now the limit of a constant, no matter where we're headed, the output of that constant function is always going to be 2/3. This output will always be negative 2/3. If we look at the two limits now, one is positive, one is negative, that means the two-sided limit does not exist.